Hello guys, welcome back. In this video, let us learn about one more important service, that is, in practical, let us learn about data lake. How to implement this S3 bucket as a data lake. So let's say I want to use any S3 bucket as a data lake and I want to do searching. I want to perform searching, in-depth searching. So how to do that in-depth searching of my data which is present in my S3 bucket. Let's say I have a website where that website generates some data regarding my clients and their orders. Now I am storing that JSON data inside my S3 bucket. So whenever a user uploaded that data, what my business requirement is, I want to process the data by using some Lambda function, and I want to put the resultant data in S3 bucket, and I further want to process that data by using some glue, that is in order to infer the schema of my JSON data which is uploaded. I want to implement a glue, and in that glue I want to store my data in the form of a table, and again I want to further analyze the data which is present in glue by using Athena, Amazon Athena. So in real time, if we talk about this, the problem statement is, let's say I have a shopping cart website. Now what I'm expecting is, whatever the user orders, that user will order, those orders I want to store at some S3 bucket. I want to upload them at some S3 bucket. Then after, what I'm expecting is, I'm expecting to update or implement the alternative action for that particular order, right? So what we do in real time, we will make a calls to the producers, and those producers can generate that products and they can deliver that product to our clients, right? Yeah. So that feedback data also we will store under some bucket, right? Yes. So, or you can say whatever the fee, whatever the orders that we get. So those total orders, what we do, we will process that whole data, and by using some any computer environment, we process that whole data and we find what are the total number of orders. So like that information I will find, and I will store that data in some target bucket, right? Then based on that, I will provide my products to the consumers, right? Yes. So for further analysis, for company requirement, to analyze how many transactions happened and how actually my data schema will be, which products are actually taking by the customers. I need to further process that data, right? Yes. So for that, I need to again store this data. I need to infer the schema of users producing events by using, we use that glue catalog. We use that glue data catalog. So in order to analyze the data which is even present in our glue catalog tables, we can use Athena. By using Athena, we can able to analyze that data. So now, first, what I told you, so whenever user event uploaded to my S3 bucket in real time, I need to trigger this Lambda function, right, to process the data. Yes. So after triggering, it needs to upload the data into target S3 bucket, and it also need to upload the data in the form of table to my glue data catalog to further process that data based on my company requirement, right? Yes. So this is how it will be visually. So whenever user uploads his data into S3 bucket, then this needs to generate some event. That is what? Put event, or you can say object creation event. In S3 bucket, we call each file as object. So this S3 bucket will generate you an event. That event is object create event. So whenever that object create event is generated, then I need to write a rule in my EventBridge event bus that I select. Currently for this scenario, I'll choose the default bus. So by using the default bus, I'll define a rule, general rule that so whenever a user object is created in my S3 bucket, then I need to trigger this Lambda function, where in this Lambda function, I will return some code to process whatever the data that it get from the event, and after processing that data, it needs to upload that data, stores the resultant data in my target bucket, and it needs to store the data in my glue catalog data in my glue data catalog tables. Right, this is what I want to do. And after storing the data in this glue catalog glue data catalog also, I want to further analyze by using Athena. So this is the whole thing that we implement in this current lab. So for this, I've already created 2 buckets and 1 Lambda function. So don't worry, I'll show you how to, I will show you the code regarding that we implement in this Lambda function, and the event bridge rule, how to create a rule for our event bridge. And we can even analyze the data that we're gonna create in this glue data catalog. Even I will show you how to create a glue data catalog by using Lambda function code in this video. So let's get started into it, and let's do the end-to-end project in this video and highly improve the searchability of data present in our data lake. Here our data lake is what? S3 bucket. So now let's start it. Now I just log into AWS Management Console. You can open and see I've already created 2 S3 buckets, one for uploading my data and one for target, one as my target bucket. You can see I've created already 3. You just focus on these 2. One for uploading my data and one for target results to store my target data. You can see under target, I do not have any data. Now I just opened my target bucket. It does not have any data. I'm moving back. You can even see I'm opening my uploads bucket. In this upload buckets, I've provided some JSON data. So these are the orders data that actually generates by using my website in real time. So for our demo purpose, I'm just using some random data. Now I'll show you some random one order, how it will be look like, and what are the fields it contains by using query with S3 select. You can see I'm just removing this limit. Now I'm just running the SQL query. You can see how the data will be. So it contains the customer data and orders data, and it also contains the shipping address. So those 3 things that particular order will contain. So this is the general data, how your data will be. So that I have provided as orders in this. So in this lab only, I'll show you, I'll upload this practically, and I'll show you that Lambda function is triggered or not after implementing whole infrastructure. Now let's move back. So I have created 2 buckets. One is for uploading and one is for targets, right? Yes. So now let's move to Lambda function and let's write code there in order to get the bucket data and object data, and it needs to process that data and needs to upload that data in my destination S3 bucket that I have provided now. And in order to create some data catalog, glue data catalog. Now let's verify, do we have any glue data catalog? I'm just opening that. before writing my Lambda function, I'm showing you under glue data catalogs. I'm opening databases. You can see, do I have any databases? No, zero databases. Now I will run Lambda. I will write a code to create that glue data catalog and upload the data, processed event data into my S3 bucket as well. So for that, I'm writing the source code. I've already created one Lambda function for us. Now I'm writing that source code here. So first we need to import the required libraries that I'm providing here. At the top, I'm importing all the required libraries. Here, if you see, I am importing this Wrangler and Pandas as well. So whenever you are importing your Pandas or Wrangler, then you need to add one layer. What is that? Pandas layer. What is that? Pandas layer. If you don't know about this layer, then you can see if you do not have any. So whenever you create your Lambda function initially, then it do not have any layer. Then you need to click on add layers. Then you need to select one AWS layer from these layers. You can see pandas. Yeah. So here pandas is available, right? So click on that and just select the version and then click on add, so that that particular layer will be added and you can able to use that pandas libraries in your code. So currently I have already added that layer, so I'm not adding again and again. I'm just cancelled that. Now we imported all the required libraries. Now to use my glue data catalog database table and to use S3 destination bucket many times, I'm just defining those two names, those two values and storing them in variables. Like in glue database, I'm storing the database name, and in target bucket, I'm storing the target bucket name, so that I can able to reuse those variables in place of my glue database. Instead of writing this name and this name each and every time, I'll use these variables so that it will be very simple to me to write in my code. So that's why I defined here them. Now I'm just writing this Lambda handler code. So in order to handle my event, whenever any event happened, then I am paraphrasing this, and by using this paraphrase event function, what I'm getting my key and bucket by providing the event to this paraphrase function. So don't worry, I'll define you that code here as well. And to read the object, I defined one more function, that is a read object. And for that I'm providing bucket and key as values. So these two, bucket and key, which I get from the paraphrase event function, I provided those two as values, and I'm getting the object body. And at last I'm also creating my database. If there is no database, then we need to create, right? Yes. So first let us implement this paraphrase event in order to get my key and bucket name from whatever the event that is produced. Now you can see I have written the paraphrase event function. I defined the paraphrase event function and I am passing the event as parameter to this function. Now based on the event, I am getting the event detailed object key and storing that in key variable, and I also getting event detail bucket name, and that bucket name I'm storing in bucket variable, and I'm returning those two, key value as well as bucket name, as returning values. Then those two will be stored under these two variables. Now I have found this bucket name as well as key by using this paraphrase event function. Now I want to read my object, right? So based on the bucket name and key, object key, I need to read the object, body of my object. So how to do that? By using this function. How to do that by using this read object function. Now I need to define that read object function. I will define that now. We can see I defined this read object function. In this, I provided two variables, that is bucket name and key, which I get in previous step. And based on that, I'm getting the object body. Here you can see, in order to create a client for S3 bucket, I'm using Boto3 library. So that's why I imported Boto3 library. And I created a client for the resource. What resource? That is S3. By using Boto3 library, I'm defining client to S3 function. That is a S3 service. Then I'm using this client, that S3 variable, in order to pick the object in the bucket, in the specified bucket, based on the particular key that I have provided. You can see I specified the bucket name here and I provided the key. Based on that, it will pick the object which is present in your S3, where this S3 is the client which was created by using your Boto3 library resource function by using S3 service. And after getting the object, what I need to get the object body, right? Yes. So you can use this get function, and within the flower braces, you need to define the body in order to get the body. And to read that, you need to use this read function and decode that in UTF-8 format, so that you got the object related body as value to this place. So since we are returning that, that particular object related body will be returned and it will be stored, it will be sent to here. So it will be returned to here and that will be assigned to this object body variable. So that this object body variable, now it will hold whatever the body, that is whatever the JSON script that was present in your uploaded file, that will be stored here, in this object body. So now before moving a step, I want to see the destinations are available or not. So for destination bucket, we have already seen that it is available. But do we have this glue database table? No, we do not have any database tables already available. So we need to create it, right? So I again return one function to create that glue database bucket, glue database table. So for that, I have again calling one function, that is create database. Now I need to implement this create database function to create our actual database. So whatever the glue database name, so by using this name, I want to create one database. So that's why I'm calling this function, and I have also written the code to create that function. You can see here. So whenever we call this glue create a database, then this will call this, then the call will go to this function. Then by using WR, what is this WR, sir? This is nothing but Wrangler. We defined AWS, we imported AWS Wrangler as WR. We can refer this AWS Wrangler as WR. So since we imported that as WR, we can refer that Wrangler as WR. By using Wrangler library only, what we are doing, we are creating a database catalog. So by using this catalog.database, by using this catalog.database, we are defining this database variable. And by using that database variable, we are finding whether our database is present in this database values or not. If our glue database is not there in our values, since no database is there, obviously no values will be there. So whatever the glue database table, glue database name that we provided, so that obviously not present in the database values at first time. So it will enter into this. Then by using Wrangler WR dot catalog dot create database command, by using WR dot catalog dot create database command, what we are doing, we are creating a catalog database. glue catalog database by using the name. What is this? Glue database. What it holds? Lab database. So by using this name, it actually creates, Wrangler creates a new database for us, and it will be printed at last by using this command, that is wr.catalog.databases. So in this way we can able to create our database by using Wrangler. Wrangler.catalog.create database. Wrangler.catalog.create database. And we need to provide the database name. So based on the database name, that our database will be created in our Wrangler. So in this way we'll create our database. Let's say if you upload object a second time to your S3 bucket, then also it will be called. But now instead of creating, it will go to this else statement and print this, that is database. With this glue database already exists, because so whenever we are taking all the databases names by using this Wrangler catalog, then this variable hold all the databases which are already present. Since while uploading my first object, it will create my database. During second object uploading, it will hold the value of our database name by using, since we are using this function to check what are the databases I have, and this function, whatever, if this glue database not in this, this will become false, because our glue database already present in our database value, so it becomes false. And then this if statement do not work, and our statement reaches to else, and this will be printed that a database, glue database, already exists. So based on your provided name, it will provide you like that information. So in this way, it will create one database whenever you're uploading your first object to your S3 bucket. So now we have our destinations like glue database catalog already available now. And then we also have what we also have that S3 destination bucket also available. Now what I need to do? I need to get the details from this object body and need to process the data and need to upload in my destination as well as my database, right? Yes. So now let's analyze what type of data we will pick. So for that, I have already shown you the JSON script by running select query. I've already shown you the JSON script, how it will be. So there we have analyzed three things. So what are the customer data we have? We have ordered data, we have orders data, and we also have that transportation data. In orders data, if you observe, we also have items data. What we have? We also have items data. Now I'm expecting to get those orders data as well as items data. So using this command, by using a JSON format, we are loading whatever the object body we get. That is nothing but our order data. So I'm loading it in my order. And in order to get our items data present in our orders, we can use in this way. We are popping that items data and we are storing that items data in this variable. So we only have orders data in orders. Since we popped the items, these orders do not have any items data, but our items variable will hold the items data, since we assigning that popped items data to this variable. So now we have order data in orders variable and items data in item variable, and we are arranging that in the form of a dictionary. In items, we are picking one by one item by using this for loop. And what we are doing here is, so by using a dictionary object, we are taking item and order ID, and we are arranging order ID and item as value to it. So like that, we are arranging again a list of dictionaries. Each item based on order ID, we are arranging a list of dictionary items. Like that, we are arranging our items and then we assign to same items variable. So what this items variable now holds is a list of dictionaries, where in each dictionary it contains item and order ID, and it also holds the order ID value. So those things that dictionary will holds. So now we created one orders data as well as items variable data. Now what I'm expecting is I want to normalize that JSON data. So in order to normalize that JSON data, we are using pandas. So here you can see what is this PD, sir. This PD is nothing but we are importing pandas as PD. So in order to use these pandas as PD, we just need to import those. And now to normalize the data, JSON data, to normalize the JSON data, we use these pandas libraries. So pd.json normalize function we are using to normalize these orders and items. And again, we are storing it in orders df. I'm assuming this df as a data frame, and items df, I'm assuming this df as a data frame. So orders data frame we created and items data frame we created by normalizing the JSON scripts of orders data and items data. Where actually how we pick our data, object data in JSON format by using this JSON only, right? Yes. So that's why we need to import that JSON as well at first. So that's why we imported these all libraries, and we have analyzed that why we imported those libraries. And in this lambda function, we picked first the key and object of the event that is generated. Then based on the key and object, we again found the object body. Then we created the database. Then we store the order value as well as the items value in normal variables. Then after we normalized that variables by using pandas library function, that is a JSON normalize. And then after normalizing the data, we are stored that in these variables order df and items df. So now we have this normalized data. Now at last, what I am expecting is I'm expecting to store this normalized data in my S3 destination bucket, that is a target bucket, and in my glue data base that I have created. So in order to do that, I'm writing the code here. You can see we have this function. What is that? WR. By using Wrangler, we are calling s3.toParquet. And we are even storing our data in the form of Parquet file because it is easy to search these Parquet files. So that's why we are using this Parquet file. Now by using this WR dot, so don't worry about these three options. I'll show you in middle. These three are nothing but variables where they hold some data. In order to use them inside my inside this, that is inside writing the data to my database. Where is that? That is a glue database. And in order to write my data inside this target database, which data I am writing? I am writing the data frame of these two. What are they? Order data frame and items data frame, right? Yes. So those two we defined here. And now we are using the orders data frame. What we are using? We are using that orders data frame. You can see orders data frame dot as a string as type str. We're converting the data frame to string format and storing that in df variable. And now this data frame, what are the data frame that we provided, that we are storing under our S3 destination bucket in this data folder, in this orders folder. At last there we are storing that data. So whatever the orders data frame data is there, that will need to store the here. But so whenever you have seen the target destination bucket, target bucket, there is no data, right? Even no folders are there. After even once running this code, Lambda code, it will create one data folder. Inside that, it will create orders folder. Inside that, it will create whatever the order that we just now storing inside that. Then it also stores the data set. So that's why we specify data set as true. And inside this database table, inside this database, it creates some table with the name, this orders. And in this mode, it will append that data, orders data inside our glue database table. And based on these partition columns, it will create our database table. And here we provided some sample description as a DESC, where DESC is a variable that holds some sample description of our table. You can see we provided some random string, that is order table, and parameters we provided by using PARAM variable. You can see under PARAM we defined two variables. We defined two key value pairs. So first one is source is one key and order web service is value, and class is one key and e-commerce is value. So like this we created two key value pairs and we store them in parameters and we assigned them to these parameters. So at last we have this column comments. So these comments we provided some random comments, you can see, and we are using those comments here. So like this we are storing our orders data frame as a string format in our target bucket as well as in our glue database table. So by using this we are doing that. Now do I need to store only orders related data? No, right? We also need to store this items related data frame as well in our destination or target bucket and our glue database. So for that, so this is the code for that. So this is the same way, that is a WR, that is wrangler.s3.toParquet, and we defined our data frame as items data frame as a string type, and we provided our target S3 bucket. So inside data, inside items, it will store that particular data that we get from this data frame. And we also providing data set is true, and we are storing the data in this database, glue database. We provided table name as items and we provided mode as append, but we provided partitions of columns as name. So that's it about the code we just implemented. That is we just read the data. So whenever a object is uploaded into my S3 bucket, then a event is generated. So don't worry, I'll show you how to do that as well. So but first now concentrate on it. That is a event is generated. So based on by using that event, we picking the key and value pairs by using this function, key and bucket name by using this function, and we are getting the object body by using this function, and we creating the database by using this function. If already database is there, then we just printing this, and then we found, then we are just picking the orders from our object body by using this JSON. Then we picking the items separately and order separately by using pop function. At last we arranged the items in our required format. Then finally we are normalizing the orders data, and we're also normalizing the items data and storing that in the form of orders df and items df. At last we are writing those order data frame as well as items data frame in our target bucket as well as our target database. So that's only we written here. Now we can even test this, and we can even check whether our database table. So initially first time what we need to do, we need to check our database is created or not. Where is that? So yeah, here we return the create database function. So that database is created with this name or not inside my glue. And we also need to verify whether in my target bucket, do these two folders, what are the two folders? So inside data will be created or not, inside data orders and items folder is created or not, inside orders and inside items do I got my data stored there or not. So those things we need to verify. Now I'll just show you by implementing a small test function. I'm just clicking on test. I'm providing a sample event. Now in this, I want to provide some sample event data JSON script, how it will be. Now I'm just pasting some sample script. Now you can see I have written that script. If you want to invoke the Lambda function directly, then you just click on invoke. So currently I'm expecting to invoke. I am not expecting to store this. So here I provided my bucket name and my object key, some random object key. You can see this object also I have uploaded in my uploads bucket. Even I can show you this. I'm opening my so before showing, I'm expecting to run this, then I'll show you. And reason is, you can see put object, I'm providing that as my event. So now I'm just invoking my Lambda function. You can see it was a testing, so it was running. Now you can see the status I got, that is 200, and hello Lambda is printed. That means it reaches to the end. Sorry, we haven't deployed the changes. Now we need to deploy the changes so that the code that we return, that will be saved and that will be updated, and that we can able to use now after testing. You can see successfully updated. Now I'm just expecting to test it again. So actually it is loading. We need to wait. So you can see the response is null. Since we haven't returned anything, we did not get any response. So that's why the null is the response. That means all our above code is executed perfectly. You can also see our database description, that is a 0 lab database. So that's we printed here. You can see after creating the database, what we did, we just printed that database that was also printed here. That means our database is created successfully. And you can also see, so it was ended with some request, right? That means our Lambda will be run successfully. We can verify that whether it created our glue data catalog database or not by going to that place. So I'm just opening our glue data catalog directly from here. Now in this glue data catalog, I'm opening my tables. You can see, so previously we did not have any tables. Now we have two tables. That first one is items table and second one is orders table. So it was created successfully. It created those two tables successfully. Now we can even see the destination S3 bucket, whether it has created that tables or not. So in destination, so this is the target, this is the S3 bucket. I'm just opening. Inside this I have three buckets. So previously in target bucket I did not have any data. So currently we have data folder, and inside this we have two folders, that is items and orders folder. And inside this items some data is there. Inside this orders also you can see some data is there. So our Lambda function ran successfully and created destination table successfully. So our Lambda function is working successfully. Now what I need to do, I need to trigger my Lambda function whenever we upload some data into S3 bucket, right? Yes. So for that we need to create an event bridge rule, event bus rule. So I'm just opening event bus. So you can even remember like event bridge, you need to open your event bridge service. So there you need to configure the rule. You can see event bridge is open, and now I'm just opening the rules. Here you can see the rules. So I'm defining my rule under this default bus. So by default, we have a default bus is available. Under this default bus, we can able to define our rules which we want to do. So I'm just clicking on create rule. So by using this rule, what I'm expecting is whenever object is uploaded into S3 bucket, then this event bridge need to trigger my Lambda function, and that Lambda function need to process that object related data and need to normalize that object and need to store that data in destination bucket as well as my glue database catalogs. Now here I'm providing my rule name, that is 1, and description not needed. So based on events based we are running, so that's why I'm selecting this event based running. And since it is not based on scheduling, I'm not selecting this. Now I'm clicking on next. So we just now provided the rule related details, like what do you provide the rule name in order to identify that rule among multiple rules. And we also provided the another thing, that is what, that is in which event bus you want to run that. So currently I'm running on default event bus. And what is the rule type? So either it is a event based or schedule based. I selected the event based rule type. So now I'm just clicking on next. Now we entered into build event pattern. So by using this event pattern, we'll generate the which type of event it is. What is the event? My event is nothing but S3 put object, right? Or S3 object creation in my S3 bucket. So that's I need to specify in this built event pattern. So in this second step, we need to specify that. Here you can see event sources. We can use AWS event sources or event bridges. We need to choose this other when we have event sources more than one, or else we can choose this all events whenever you are expecting to writing a rule for all the events. Now I'm just selecting this because my event is just creating an object. And here you can able to sample define an event. It's an optional. If you want, you can define, then no need. So currently for your understanding, I'm just providing you the glance. So I'm returning S3. You can see object create. So whenever you click on it, then that will be generated. So that's it. You can able to copy and paste here under your creation method by using this custom JSON script, or else you can simply use pattern format to define that. That is AWS services only. My event source is, sometimes your event source may be another event bridge partner. You can select that if you are using that type of event bridge. Now I'm selecting the service provider, that is nothing but S3. I selected that. And what is the event type? So it belongs to S3 event notifications. And which type is event type? Specific type, that is object create. I just selected that. Now I'm just moving on to down. Any bucket or specific bucket? I want to define specific bucket for specific bucket. So I'm opening again my S3 buckets, and I'm copying my upload bucket name. Now I'm pasting that name here. So I pasted that name. Spaces, extra spaces are there, then remove that. So like this, you need to define your build event pattern. So what is the source? What is the source that you need to define here? That means what is the event pattern that you need to define here? Currently, I'm defining my event pattern as what? Upload object. Inside my S3, inside S3 event notification, I'm provided my object creation as my event. And for this bucket, I'm considering this event, not for all the buckets. That also is specified. You can see an automatic event pattern will be generated. So if you are expert in writing this JSON script, then you can able to choose this custom patterns and you can write it there as well. And if you want to use any schema, then select this and provide your schema related details. So currently I'm expecting to move on with this use patterns form. Now I'm just clicking on next. So we have done how many steps? Yeah, first step we defined the rules, and we say second step we defined the event pattern. In third step we need to define the target. What is the target that we need to trigger? Whenever an object is uploaded, we need to trigger S3 bucket, right? Yes. So here we have three types of target: EventBridge, event bus. Either if you want to trigger another event bus, then you can choose this, or else if you want to trigger any API destination, then you choose this, or else if you want to choose any AWS service, then choose this. So currently I'm expecting to define my Lambda function or trigger my Lambda function. So that I selected this and I searched for Lambda function. You can see I got the Lambda function. I selected that. Now I'm selecting the function. My function name is Lambda upload. Now at last, so these two are optional. If you want, you can able to provide this details. Now I'm just clicking on next and tags. So these tags are also optional. I'm just moving on. Since currently for this requirement, I do not require tags. Now, at last, you have the review session. So during this session, you have also edit option, or else you can go to any step by clicking on that step. Now I'm just scrolling it up. So after reviewing your data, you just need to click on create rule. You can see I defined my rule by using this name, and I am using my default event bus, and I defined my pattern, and I defined my target. So at last I'm just clicking on create rule. So it will create you a own rule. So you can see a message a message will be appear, that is a rule with the name. This rule 1 was created successfully. You can even see that rule here. You can see that rule is available here. So that is even enabled. So even you can verify that rule is created by using a Lambda function. Since you are triggering Lambda function, a trigger will be added to your Lambda function. So automatically, you can see I'm opening my Lambda upload function. It was loading. We need to get a trigger here. Since we created a EventBridge and we are triggering, yeah, you can see a EventBridge rule is applied here. So by using this EventBridge, based on the rule 1, it will trigger this Lambda function. Now you can see how many times this Lambda function even worked, and you can also see how many times this EventBridge also, how many times your EventBridge worked in your EventBridge by opening your EventBridge. So currently I have triggered this Lambda function only once. So I think only one triggering it will show. You can see under the dashboards how many invocations are there. Only one. Okay, 2 invocations are there. Yeah, only 2 invocations are there. Now what I'm expecting to do. So in order to verify that EventBridge rule is working or not, to verify my EventBridge rule, what we defined, that is working or not. So whenever I upload my data into my S3 bucket, then this rule is working or not, and it will trigger my Lambda function or not. So it will invoke my Lambda function or not. You can see, you can also see the metrics under your rule, whether it is invoking your Lambda function or not. So currently for your rule that you created in your EventBridge, there is no invocations happen. So you can also see here under your rule. So whenever you upload your object to S3 bucket, it need to invoke, or it need to invoke your Lambda function. This EventBridge rule need to invoke your Lambda function. So that you can able to verify from this monitoring metrics, that is invocations in your rules that you created. So you need to invoke my Lambda function. That Lambda function need to work and need to normalize my object that I have provided, and it also need to put my data in under my S3 bucket and my glue data catalog database table, right? Yes. So let's verify that. Now I'm just opening my S3 bucket and I'm opening my objects, and I'm downloading one of my objects, and I upload that object again in any one of the folder, or I can rename this and re-upload it so that it will be done. Now I'm just downloading that file. So it was downloaded successfully. Now I'm opening my bucket, uploads bucket. I'm expecting to upload and verify whether whole thing, whatever the thing that we constructed by using a event bridge, rule, lambda function, and so those all things were working or not. So let's upload a file. I'm just selecting the file. You can see orders.json. I'm just uploading it again by clicking on upload here. You can see the file is getting, yeah, it is uploaded successfully. You can see file is uploaded successfully. Now I'm just closing this tab. Now I'm expecting to see my event bridge. I'm expecting to reload this data. This is my event bridge rule that we have defined. Now I'm expecting to reload and see this data. You can see there is no invocations are there. I think since we uploaded the file with same name in the same folder, so that's why it was not considered that as upload. Now we'll upload that folder, we'll upload that file inside another folder. So let's create one folder inside our uploads bucket, and we will upload the same file again in the new folder. Now you can see we are under our uploads bucket, and inside the uploads bucket I'm just creating one folder with some random name. Now I'm just clicking on create folder. Everything we configured correctly. You can see a folder was created successfully, so that's also visible. I'm just opening that folder. Now I'll upload the file. So I just clicked on upload and I selected the add files and uploading the file. Now I just clicking on upload so that this file will be uploaded. You can see the status. Yeah, it was uploaded successfully. Now we'll go back to our rules. So that is I'm just closing this. I'm just opening again my this event bridge rule and just reloading this. You can see, yes. So one invocation was happened successfully. You can see this. Yes. So 41 invocations, that means some invocation is happened. Clearly we can see by using this point, some matching event is also detected, that is a uploaded event, that also detected in triggered rules. So since one rule is triggered, you can see one is detected, and in injected injection to invocation, so something, so like that you can see your rule is working. Whatever the rule that you defined inside your event bridge rules, that is working. Now we can even monitor whatever the lambda function that we created. So based on triggerings or invocations, we just refresh this so that we can able to monitor that particular things. So now I just entered into my lambda upload function. Now at here I opened my monitor tab. Now I'm just clicking on reload option here. You can see all my matrices are reloaded. You can see, yes. So here the runtime will be changed and number of invocations also changed. That means my lambda function was triggered or invoked and throttles. So my lambda function is invoked. Based on this monitor matrices, I can able to say my lambda function is triggered, and whatever the code that I have written that also triggered, that also run successfully due to this event bridge rule triggering. And let's verify whether my data was uploaded in my destination S3 bucket or not. So I'm opening my target bucket in S3. You can see under data, you have items and orders folder. Let's open orders folder. Previously we have only premium customer type. Now currently you can see customer types as customer and business type as well. So I hope two more folders are created, and inside those two again some more folders, internal folders, and some more data is also created, that is parkway data. That is a normalized data is created, uploaded successfully by using this lambda function. Now let's verify. At last, let's move on to glue and let's verify that whether it also contains the data or not. I'm just opening the glue. Inside this databases present in your data catalog, I'm opening the databases what I have, and inside the databases I have two tables. Orders table I have, and I also have items table. Currently I'm opening orders table. Inside this orders table you can see I got the schema. That means I got the schema. That means it can able to get the data of it. That means this glue data catalog table can able to store the schema of our uploaded object, and we can even see the data which is present in our table by using this option. At the rightmost corner you can see under actions view data option. You just click on it so that it can move to Athena. So this is what the important thing that you need to remember. So you can simply redirect it to Athena. If you click here, you simply redirect it to Athena. From there, now I'm just clicking on proceed so that it redirected to Athena. From here, we can able to analyze the data stored in our data catalog. You can see the data catalog is available. So under our data catalog, so whatever the lab database I have, so that you can able to query that data. So based on the created work group, you need to acknowledge that, and from there you can able to see the data present in your orders table or else items table. Now I'm just clicking on preview the table. I'm expecting to see all the data, so that's why I'm removing this. I'm just clicking on run. So you can see it was running. So totally 93 results. So our data is even stored in our glue data catalog. For further queries you can able to implement by using Amazon Athena, and you can able to use glue data catalog. That is a glue data catalog will act as a, you can see the data source, that is a AWS data catalog, that is a database. Whatever the lab database that we created under our glue data catalog by using Lambda function, that even available here, and the database tables that are created under our glue catalog that are also visible here. We can able to analyze that data centrally by using this Athena, and EMR also we can able to analyze that data. So here we can monitor two things, that is centrally we are managing whatever the S3 data or data lake data that we stored in S3 by using glue catalog, and we are even analyzed the data stored in S3 by using a Lambda function, normalized that data and store that normalized data in S3 bucket as well. For further analysis, we stored that data in glue data catalog, and we can even able to analyze that data by using this AWS Athena. That glue data catalog database table containing tables data that we are analyzing using Athena. You can observe that point from here. Now, at last, I would like to specify one important real-time implementation trick, that is, you can see how much data it is scanned. It is scanned 83.77 KB, right? Yes. So now in real time, so scanning this whole data will cost you a lot, right? Yes. So in order to partition your data and scan very less amount of data, you can you can do that in your glue data catalog. So under this glue data catalog, you need to create some indexes. You can see I opened my glue service. Inside this glue service, I opened my databases. You can say I'm just clicking on databases. I opened my database. Inside that database also, I am opening particular table that I want to query. And inside that table also, I open currently orders table. And inside that table, in real time, what you create is you create some indexes. You can see schema is there, the table related partitions are there, and you can even see indexes are there. So by using these indexes, you can able to partition your data. Column statistics also available. So currently I'm moving on with adding the index, so that in real time we can able to query the data by scanning only particular, by partitioning data only. You can able to scan your partition data by using these indexes. Now I'm just clicking on add index. Here I'm entering my index and name. I'm just providing my index and name. So you can provide some random. In orders, I filtered my data based on customer type index. So that's why I written this name, and index type you need to select based on customer type you want to filter, or order shipping address you want to filter. Currently I'm expecting to filter based on customer type. So that's why I selected that. Now I'm just clicking on update so that your index will be updated here. You can see it is on creating state index. So after your index is created, you can able to query your data. So based on this custom type, you can even further query your data internally. That means you can able to scan only less amount of data and you will be charged very less based on this indexes. You can see our index is now active. Now let us see how to query the data by using this indexes. So that also I'll show you. I opened my Athena lab. Now let's exclude the premium customers data. Now I want to see only business customers data and consumer customers data. So by using this custom type, I want to analyze that. So that's why I opened my Athena function, and I again processing on my orders data inside my lab database by using this command, where this custom type is this business type or this consumer type. So I'm just running this. Now you can see the data is reduced. Now to analyze this particular custom type scanning, I also expect to do only scanning by using one attribute. So that's why I'm just clicking on plus, and now I'm adding one more command. That is, now I'm just filtering only business types. So in custom types also, I'm just filtering only business types. You can see I'm just running it, and let's analyze how much data it is scanned. You can see only 65 kbs it is scanned. So for analyzing this business data based on this custom type, this Athena scanned only 65 kbs. That means the amount of data that is scanned will be reduced, right? Yes. You can see under query 1 that we scanned both business data and consumer data. So in that case, exactly double, that is 125 kb is scanned. But whereas if we scanned in query 3, so what happened if we scanned only business data, then what happens? Only 65 kb is scanned. That means, so based on this indexing that we provided in the glue, and based on the consumer type, by using that indexing, what we did, we reduced the amount of data that we are scanning. So that means in real time scenario, this makes a huge profit to you. Since the amount of data scanned is very less, in real time you may have much more large data sets. So during those scenarios, during those times, so this will be highly helpful to you to reduce the cost. So in this way, you can able to further analyze your data stored in S3 by storing the schema and table in your glue, and by analyzing that data by using Athena, and you can able to reduce the cost for that analysis by providing some indexes in your glue data catalog database. So that's what this lab all about. We are using S3 bucket as our data lake, and we uploaded our data into S3 bucket. So whenever a data is uploaded into my S3 uploads bucket, then we are just triggering our then so whenever that event happened, that is object create event happened, then in this event bridge we defined a rule, so that rule will trigger this lambda function. Then This Lambda function will normalize the data, and then this again upload the data into whatever the destination bucket that we provided, that target bucket we provided in S3, and it also uploads the data. That Lambda function also uploads the data in our Glue data catalog. So this is the Glue database catalog tables. So inside that it will upload the data, and we can able to further analyze the data for future purpose by using this Athena queries. So in order to reduce the cost while analyzing that data, we also introduced you the concept of indexes. So that concept also we have seen. We have also seen how our data scanning will be reduced if we use this custom type index. So by analyzing two queries, you have seen the amount of data scanned. So that's all about this lab. I hope you catch the point of implementing searchable data lake in real time and reducing the cost while implementing searching in that data as well. I hope you understood this video and you got some on how to implement your S3 bucket as a searchable data lake in real time, and you also got some knowledge on how to create rules in your EventBridge, and you also seen how to trigger your Lambda function. That is in real time how to analyze your data lake, how to implement searchable data lake. So that you have learned from this video by using this end-to-end project. I hope this video is helpful to you. If you feel this video is helpful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys. Thanks for watching again.